Hello everyone, I am Vihan, and what I have with me right now is the final key you need to unlock your perfect score on AP Precalculus. Now, unlike other one-shot reviews, I've tried to provide you with the exact content that is tested on the exam. I've seen one-shot reviews that are an hour long and have 25-paged short reviews. So I've tried my best to avoid this. There are two ways you could utilize this precious review. I would recommend that you go through the entire video with me. I'll provide you clarity and I'll explain the document as well. Or you could directly access the PDF I made. I'll provide the link in the description below. If you do so, no problem. Utilize it efficiently. But please do take the pains to leave a comment or a like at least, because at the end of the day, I too am a 10th grader. So let's begin without further ado. Now, here are some things I hope you already know. We have the difference of squares, which is a square minus b square, which is a plus b times a minus b. There are two ways you can find the roots of a quadratic equation. One is by splitting the middle term, and the second is the general quadratic formula. Now, 95% of the times on the AP test, you will be asked to find the roots using splitting the middle term, which I think is more than enough. You should be thorough with this. But if not, just in case uh, the function that you have is not factorable in this form, you should be aware of the quadratic formula. So on test day, you can quickly plug in the values and get the roots. But I recommend that you be thorough with this method and don't worry too much about this one. And I also hope that all of us are clear with basic algebra, including the law of exponents. Let us now move ahead to the actual content. All right, number one, we have discontinuities. There are three kinds tested on the AP Precalculus. We have a jump discontinuity, a removable one, and an infinite one. As you can clearly see in the graph beside me, at x equal to -5, we have a jump discontinuity. And a jump essentially means that the graph jumps from one y value to another. For example, not only is f of -5 not defined at the particular point, but the values that the function takes before -5 and after -5 are very different. That was the jump discontinuity. The removable discontinuity is that, as you can see in the graph that I have here, f of x is not defined at x equal to 1, but it is defined for all values near 1. For example, it is defined for 1.1 or 0.9, but not at 1. And the last one, which is an infinite discontinuity, which means that the limit as x approaches phi will tend to either negative or positive infinity, and f of phi is not defined. Number two, I have the intercepts. These are quite common. We have the x-intercept where the output is 0. The coordinates are of the form x comma 0, and it has many values. We've seen cubic or quadratic polynomials with 3 or 2 zeros, whereas the y-intercept, the input is 0, the coordinates are of the form 0 comma y, and it has only one value. I've tried to illustrate it beside me. For example, if we have the green function, which is not exactly a function, I'll explain you in a moment. So if I have a green function which intercepts the y-axis at three places, the three circle points, this means that x equal to 0 as an input corresponds to three different outputs. And we know from the definition of a function that one input can correspond to only one output, which means that it violates the definition of a function. So there is only one y-intercept for a graph. Number three, zeros. Now, the behavior of a graph depends on the multiplicity of the zeros, and multiplicity refers to the number of times a zero occurs. For example, the 0 x equal to 2 at x minus 2 whole square has a multiplicity of 2, whereas if it is raised to the power 3, it has a multiplicity of 3. Now, if the multiplicity is odd, it implies that the polynomial crosses the x-axis. I have illustrated it beside. And if the multiplicity is even, the polynomial is tangent to the x-axis. The converse of these statements hold true as well, which means that even multiplicity implies tangency and tangency implies even multiplicity. It is also to be noted that a polynomial of degree n has at most n zeros. Number four, functions. We don't have much here. We have even functions and odd functions. In an even function, a negative input is same as a positive input, or a negative input and a positive input have the same output. It has symmetry to the y-axis, and x squared is a classic example of an even function. In an odd function, a negative input turns the entire output negative. It has symmetry to the origin, and another good example is x cubed minus x. Number 5, we have limits, very important. Now, I couldn't figure out how to add a table in LaTeX, so I recommend that you take some time to make a visual representation as I made it over here. It'll make it much more easier for you because the limit notations actually make it look much harder than it is. It seems like you have to memorize a ton of limits, but if you arrange them in this table, for example, you have the coefficient, the degree, and the limit as it approaches positive or negative infinity, it'll be much more clear to you and it'll be easy for you to grasp. Moving on, we have number 6, binomial theorem. If n is a positive whole number, then the expansion of a plus b to the power n is as follows. Now, if you are still not clear with the binomial theorem, I recommend you watch one of my videos. I break down the binomial theorem into 3 very simple steps, or you could watch some other video and be thorough with the binomial theorem. Don't ignore this because of its complexity. They will have at least 1 or 2 questions on the MCQ part about the binomial theorem, so I hope you'll be thorough with it by the time your test comes. Number 7, asymptotes. This is again a very important concept. We have vertical asymptote. If I have my function f of x as p of x upon q of x, so in short, f of x is a rational function, then the line x equal to a is a vertical asymptote of the graph of f when q of a, which means the denominator, is 0, but the numerator does not equal to 0. This is a very strict condition, and people often confuse between a vertical asymptote and a hole. I'll make holes clear in a moment too. Before that, we have horizontal asymptotes. Consider the rational function we took before. If I have the degree of the numerator to be n and the degree of the denominator to be m, then I have 3 cases. If they have the same degrees, the rational function has a horizontal asymptote as a fraction of their leading coefficients, which is an upon bm. Case 2, if the degree of the numerator is less, the rational function has a horizontal asymptote at y equal to 0. And the third case, which is the opposite, if the degree of the numerator is larger, the rational function has no horizontal asymptote as such, but the end behavior could be found by long division. Finally, moving on to holes. Now, there are a few steps you need to follow before you get the coordinates of the holes. We start by completely factoring the polynomial. So I have taken an example here where I have x minus 2 times x plus 3 upon x plus 5 times x minus 2. I clearly notice that I have x minus 2 as my common factor, and I take the zeros of the common factor, which means x minus 2 equal to 0, which yields x equal to 2. I plug in x equal to 2 into the remaining polynomial, which gives me 2 plus 3 upon 2 plus 5, which is 5.7. So I have the coordinates of my hole as 2 comma 5 by 7. Now, a mistake many people do is that they consider x equal to 2 to be a vertical asymptote. But as I mentioned above, the numerator should not be equal to 0. In this case, x equal to 2, the numerator also tends to 0 as well as the denominator. So this will not be asymptote, rather it will be a hole. I hope the difference between the two is quite clear. Number 8, inequalities. This is again an important topic, but there is no specific theory you need to learn for inequalities. However, there is a procedure with which you need to be thorough. Step 1, we rewrite the inequality in the form of f of x less than 0 or greater than 0. The motivation behind this step is that we can quickly recognize whether a required function will be positive or negative. Step 2, determine the critical values. It could be a 0, an asymptote, or a discontinuity. Step 3, we plot the critical values on a rough number line I've shown you above. For example, if I have my critical values as -3 and 2, I plot them on a number line and I roughly get my intervals. Then I test exactly one value easy to evaluate in each of the intervals obtained. Here, they could be -4, 0, or 3. And step 4, we write the solution intervals. I hope that was clear. Number 9, we have sequences. Now, unlike other topics that I discussed earlier, sequences is comparatively a less important topic. However, I recommend that you be thorough with the nth formula for both AP and GP. An is equal to A plus B times n minus 1, and Gn is equal to G times R to the power n minus 1. Now, the sum formula that I have here, which is the sum of the first n terms, I'm not sure whether you have it in your AP Precalculus syllabus or not. So I've kept that in case, just if you might want to review it. But I think that you should be thorough with the nth formula, but there's no need to learn the sum of the first n terms. Number 10, I have a few things on inverse and linear functions. First, we have the average rate of change, right from algebra 1, y2 minus y1 upon x2 minus x1. If you want to model a linear function, we have y is equal to mx plus b, where m is the slope and b is the y-intercept of the function. Talking about inverse functions, if we have a function f of x and if f of a maps to b, then f inverse of b maps to a. Simply, f of x maps the inputs to the outputs, but f inverse of x, as the name suggests, it actually maps the outputs to the inputs. Number 11, we have transformations. I'm not planning to go into each one of them in great detail. I have a video on this, or there are many other videos out there that explain the transformations. I just want to have a recap here. So vertical translation is concerned with moving the graph up or down. A horizontal translation is concerned with moving the graph left or right. A vertical dilation is concerned with dilating or shrinking or expanding the graph vertically, and horizontal dilation is concerned with shrinking or expanding the graph horizontally. And we have the compact representation, which is y is equal to a times f of b times x plus c plus t. And many people get confused about which constant is a translation. Is it a dilation? Is it horizontal? Is it vertical? So remember that whenever anything happens with the input, it is always horizontal. Whenever anything happens with the output, it is said to be vertical. For example, the point D here, the point D is something that happens with the output. But if you look at the points B and C, it's something that happens within the f of x. So they're supposed to be horizontal, right? So anything that happens with the input is horizontal. Anything that happens with the output, like A and D, is vertical. Now, whenever you have multiplication, it is always a dilation. And whenever you have addition, it's always translation. So for example, if I look at the point C, I recognize that it is something happening with the input, so it should be horizontal. And since it is addition, it is translation. And if I look at the definition of point C over here, yes, C is a horizontal translation. So this is one way in which you could memorize which constant refers to which transformation. And I think that would be it for this one. Number 12, we have function composition. Again, a very important topic. It will be tested on your FRQ and MCQ as well, but it does not have a lot of theory. So given two functions f and g, the composition function is f of g of x. So if I ask you to evaluate f of g of 2, which means you first take your g of x function, take 2 as the input, get output, and the output you get from g of x is what you put as the input to f of x, and that's how you evaluate the composition. It's very simple. Generally, f of g of x is not equal to g of f of x. The process is not commutative. This is a very simple concept, I guess. Moving on to number 13, logarithms. Again, a very important but a rather simple concept if you understand it. So if we have constants a, b, and c, and if log base b of c is equal to a, it implies that b to the power a is equal to c, and that is essentially what a log does. A logarithm is another powerful way to express exponents, and the main function of a logarithm is that it tells you what power do you raise b to get the number c. For example, if I tell you log base 3 of 27, it means what power do I raise the number 3 to get 27, and the answer would be 3. Now, there are a few basic rules which you need to be very, very thorough with, especially the product, quotient, and power law. They are very important and they will be tested frequently on the AP Precalculus exam. I haven't seen the change of base being applied too much, but again, you have to learn it. It's quite important. And apart from these rules, we have the natural logarithm denoted as ln of x, and it has the base as the rational number e, which is called the Euler's constant. In the way we have log of x with the base 10, we have ln of x with the base e. And since log 10 is equal to 1, in a very similar way, log e, which means e to the power 1 is e. So ln of e is 1. And the laws of ln of x hold the exact same as the ones for logarithms. I hope you are very thorough with this. And yeah, let's move ahead. Now here I have the trigonometry value table with me right here, and I highly recommend that you actually remember all of the values. Without it, it will be difficult for you to score well on your AP Precalculus exam. Now there is one shortcut that I use to remember this. First of all, I remember all of the sign values. So you should be very thorough with your sign values, which means 0, 1 by 2, 1 by root 2, root 3 by 2, and 1. If you are clear with this, then you can automatically find out the other. So cosine is just the reverse of sine. For example, if I have 1 at pi over 2, then that one is right here. If I have root 3 over 2 at pi by 3, then I have root 3 over 2 at pi by 6. You see how it's getting mirrored. So if you know the values of sine theta, cosine theta is just the reverse, and tan theta is basically sine theta upon cos theta, right? So once you have the values of sine and cosine, you basically divide to get tan theta. And once you're done with the three of these values, the next three of them are just reciprocals of the respective values. For example, if I were to find cot of pi over 3, then I know tan of pi over 3 is root 3, and the reciprocal of root 3 is 1 over root 3. So cot of pi by root 3 would be 1, or pi by 3 would be 1 over root 3. And that way you can memorize the entire table. I hope that was useful, and now let's move ahead. Number 14, sinusoidal functions. Again, a very important topic, keeping in mind that you have FRQ3 based on modeling a periodic context, and you may as well as have something in the MCQ section upon sinusoidal functions. There are a few pointers which you need to be thorough with, starting with frequency. So frequency is the total number of cycles that a graph completes in an interval of 2 pi radians. And as we know, both sine and cosine have a frequency of 1 as they complete one full cycle every 2 pi radians. Now, many people, including myself, confuse between amplitude and midline. So I have boxed the equation to make it much more clear for you. So amplitude is half the difference between the maximum and the minimum values. And since we have the maximum and minimum as 1 and negative 1, we have the amplitude to be 1. And the midline is the average of the maximum and minimum values. And for sine and cosine, the midline will be y equal to 0. So keep in mind amplitude, difference of max and minimum upon 2, and midline is the addition of max and minimum upon 2, or just the average of the maximum and minimum values. Now, you have to keep in mind whether sine and cosine is an odd or an even function. So, sine function is odd. It has symmetry with respect to the origin, which implies that sine of negative theta is equal to negative sine theta. And we have that cosine is an even function because it has symmetry with respect to the y-axis, which implies that cos of negative theta is just cos of theta. Now, the transformations may be summarized as follows. We have the function f of theta to be a times sine b of theta plus c plus d, where a is the amplitude, b is the frequency, c is the horizontal translation, and d is the midline. Let's move on. Number 15, polar coordinates. We are finally moving towards the end. Now, just like the Cartesian coordinates are of the form x comma y, polar coordinates are of the form r comma theta, where r is called the radius and theta measures the angle. The following are the rules needed to be taken care of. A positive sine of theta implies a clockwise rotation, And conversely, a negative sine of theta implies an anti-clockwise rotation. That is quite self-explanatory. Now, a positive sign of radius denotes the conventional extension of the ray, but a negative sign of the radius denotes a reflection of the ray by 180 degrees or a rotation of the ray by 180 degrees from the conventional direction. I've tried to illustrate it with the diagram beside the marked points here. So conventionally the ray is facing north, but after rotating it 180 degrees, it is in another position, which is negative radius. That's how you denote negative radius. You first move it clockwise or anti-clockwise, and then you rotate it 180 degrees. Moving on to number 16, polar conversion, again a very important topic. So to go from polar to rectangular, we have the following relations. The x-coordinate is just r times cos theta, and the y-coordinate is y is equal to r times sine theta. But if we want to go from rectangular to polar, we have more complex relations. So for the radius, it's quite simple. You just take the square root of x squared plus y squared. That gives you the radius. But for angle theta, we have four cases depending on which quadrant does the point lie in. For example, if it lies in the first quadrant, we have theta is equal to arctan of phi over x. If it lies in the second quadrant, we have a different case. If it lies in the third and fourth quadrant, we have more different cases. And you should be thorough with them. I've mentioned them so you can review them quite well. Finally, we have number 17, polar numbers in complex form. The polar form of the number of the complex number z is equal to a plus bi is written as z is equal to r times cos theta plus I sin theta, where again we have r as square root of x squared plus y squared and theta is equal to r tan of b over a. Take this as a revision, something that you can go over through the last day of your exam. I think we're at the end now. If you found the PDF useful or if you found the review or the video useful, please leave a like, comment, or share because I've put in hours of work into making this PDF, particularly because it takes a lot of time to input the code in LaTeX and then format to get a particular review. So I'll be very happy if you take the pains to like, comment, or share. Thank you. I hope you enjoyed this.